So this is the fourth video of our process control day 3. We're going to talk about out of control conditions, special causes, and we are also going to give you a brief little summary, and then we will talk about the worksheet that you'll need to complete. So here's two processes. Process A shows common cause variation. Process B shows special cause variation. There's a number of different special causes that we're going to see. These special causes, these three, are indicated by points outside the control limits. There are other ones that would be represented by data within the control limits, just not patterns that are considered normal. Process B, in addition to showing these special causes, process B does have common cause variation as well. If you remember, all processes do have that normal variation that we would consider common to a process. So the process A just has common cause variation. Process B has both special and common cause variation. There's a number of different tests for special causes, and what I'm going to do is I'm going to focus on these four. And if you can have your operators focus on these four, let the softwares do the rest. These are probably the four most common and the ones that are easiest to recognize when you're looking at a chart. As you start to look at more charts and more data, you'll start to pick out some of the additional ones. But for right now, for yellow belt training, this is more than enough how to interpret a control chart. The nice thing about this is once you are able to interpret a control chart, you can look at data from any process representing any particular environment and be able to discuss normality. Is the data usual, normal or not normal? So when we see a point that fails a test for a special cause, we're going to consider that data not normal, and again, that condition would be out of control. There's two things that we're going to want to do. We want to first verify that data, and then if the data was plotted correctly and it was calculated correctly, then we're going to go in and investigate the cause of that non-normal condition. So here's a particular chart. It's an X bar and R chart. So we have a top portion and a bottom portion. The top portion looks like it's relatively stable. I don't see any patterns or anything that would cause any alarm. Same thing with the bottom. So this is normal variation. This would be considered a stable process. So the first test is there a point beyond the upper or lower control limit? It can be on the top graph or the bottom graph. And in this particular case, we've got an out of control condition, 1 point outside the control limit on the top graph. This is a special cause. Something caused that to happen. I want to then go back into my process and determine what caused that to happen. Seven consecutive points without a change in direction. This can be going down, it can be going up, and again, it can be on either one of these two charts. This particular case, there's 7 consecutive points, and we're going to consider this a trend. When we see this, something's causing that to happen. And again, I'm going to go into my process and I'm going to find out what caused that to happen. I don't want this to happen, so I want to go in and find out what's causing that to happen, and I'm going to fix things within my process so this does not happen again. It's part of that taking that corrective action. A process shift. Think about your chart. You have an average, and half your points should be above and half your points should be below. 8 consecutive points on the same side of your center line is enough to say statistically that should not happen. Something's caused my process to shift. It can shift either high or low. And in this particular case, the range is shifted, which means the variation is more than what I would normally see. So I want to know, why am I seeing more variation than normal? I'm going to go back into my process and see, is there something wrong with my my machinery or my process that's creating this out of control condition. Okay, we want to do this before we start creating defects for our particular customer. So hopefully, even though in this particular case I'm not outside my control limits, I would expect over time that I would be violating my control limits. But right now I can definitely say that I've got um, out of control condition here, and this is a sign of a special cause. Something's creating this not normal to my process. Lastly, we have stratification, and in this particular case 15 or more points within one standard deviation unit. We're going to remember I referred back in the previous presentation about the different zones. So plus or minus one standard deviation, if you recall, we were supposed to see about 68% of our data. When we see more than 68% of our data, things are starting to not look normal, but we're not going to call it out of control. We're going to call it out of control when we got 15 points in a row within that center line. Now, a couple things may cause this. First of all, if somebody is just pencil whipping a chart and giving you what they think you want, it's going to look something like this. There's not that normal variation. Something's causing that, and it's an operator or technician giving you what they think you want. And really what you want is you want accurate information from your process so that you can react to and improve that process. Another condition that you would be looking for is maybe something changed in your process that made your process better than it should be. My process should not be operating as tightly as this. And I want to find out what caused that. This is a condition that's actually preferred, right? We don't want to have a lot of variation. So when we don't have a lot of variation, I want to go into my process and say, what's causing that? And maybe our regular operator went away and we have a new person that comes in that used to run the process years ago, and that new person is following the procedure to the letter of the law and not creating a lot of the variation that we normally see with the existing operator. So there's different reasons why we would see this. The bottom line is we're not going to see it we're not going to understand why this happened looking at a chart. All the chart is telling us to do is say, okay, something not normal happened. Go back and look in your process to see if you can figure out what happened. Okay, so all these special causes are just going to cause us to go back and look at the process. We don't want to look at the process when it's acting normally. We want to go back and look for something not normal happening. So we've looked at a lot of different ways to present data. We've seen cause and effect diagrams. We've seen Paretos, histograms. We've even seen some other ones. I'm just thinking about the dot plots that we showed you. We saw a flow chart, but we also saw a spaghetti diagram. So we've introduced you to these 7 basic quality tools, but we've also showed you some other ones too. How you present your data and show it to management or team members or other individuals to get buy-in is up to you. But now hopefully you've got a little bit better understanding of some of these tools and how you might be able to utilize them to sell your project and sell your enhancement activities. What we'd like you to do now to earn your certification is complete this last worksheet. This is the process control worksheet. The expectation is that you would create a Pareto using information from your workplace. Maybe issues or counts of defects, something that can be representative of or by a Pareto chart. We're going to ask you to label your Pareto chart. Your Pareto should have a nice description of where this data came from, the time period that the data was collected, and each of the different bars along the bottom, those categories should be labeled properly. We'd like to see a cumulative bar, that red line on your chart too, and we will have provided you a Excel file that shows that. If you draw this by hand, perfectly acceptable. People draw them by hand, scan them, and fax them to us, or not fax, send them to us electronically, more than acceptable. The last part of this is, now that you've created this Pareto, tell us what you're going to do with this information. Describe this Pareto and then tell us how you might use this to enhance your process. We're not looking for 3 pages. We're looking for 2, 3 sentences on this to satisfy the section C of this worksheet. Good luck, and certainly if you have any questions throughout this process, please email us, and good luck to you.